Alrighty, so this question asks you to calculation R1, R2 with gain of 26 dB, okay? Question number one. If you look at this one here is, so we have 26 dB, we use 20 log voltage gain here, right? And then we remember just do this calculation absolute value, okay? Because this cannot be negative. Is minus R2 or R1, right? 26 dB, R2 or R1, 10 raised to 26 divided by 10, okay? And you got 10 of 1.3, and you got this. So R2 or R1, 20. So want to calculation this like, R2 will be larger, okay? You want to calculate smallest R1, right? Ask the smallest, right? No larger than 100K, right? Right? It is the only way it can be is cannot be R1 is 100K. If R1 100K, R2 will be like 200K, right? So this R2, right, should be 100K. Then R1 should be 5K, right? Yeah. So this is question number one. Question number two is is this. Question number two is asking you to is uh, find this like uh, particular particular this particular this one here, okay? So he gave you this inverting case, right? Inverting case is the inverting case is has is R1. Make it bigger here. R half R here, so on and so forth. Ask you if find the resistance. Look into the R node one, R1, node R2. Okay, find resistance. Okay, right. So resistance wise, you can use like Thevenin theorem, right? So for Thevenin theorems is looking from this side to this side, right? But looking at Thevenin theorem is this and this together should be parallel, right? If the parallel become half R, and then become half R plus um, half R, right? And node 1 is called R, right? Node 1 is R, right? Node 2 is node 2 here, right? And this half R plus half R is R as well. So for node 1 is R, node 2 is R, node 3 again, right? Again, just half R is 1R. 1R here, based on Thevenin theorem, this is 1R here, half R again. Half R plus half R is 1R. So both 1, 2, 3, 4 is R, okay? So another one is the current. Again, utilizing Thevenin theorem is we know at this point, right? From this point to this point here, and from this point to this point here, the current should be same. Why? Because the same this side here same ground, this side here is same voltage, and the resistance also same. Therefore, the current same. We also know this one here. There's no input current here, so all the current from here will go to here. So that means this one is R. Because this one is R, right? This one's R is from this direction to this direction. Okay. Sorry, from this direction to this direction. Okay. And this is R as well, okay? This is R, okay? So this is R, this is R, and I1, right? I1 is R, right? And this is R here. I mean, notice I, and this is I, this is I, right? This is I, this is I, right? Right? And this is 2I, right? Right? And this will be 2I, okay? Right? Let me show you here, should be more specific. We know the R here, right? All this one should be R, okay? Question number B is 2I here, right? As a 2R, 2I. 2I, 2I here, right? And this one, flow direction from this one here, right? Should be 4I. You 4I here, 4I here should be 8I, okay? Question number C is the voltage. The voltage here is the first one. The voltage here should be I multiplied R is minus IR, right, for this voltage one. Why? Because this one is the reason is because the current flowing from here to here, right, from here to here, and this is zero voltage. Must be negative. Why? Because if not negative voltage here, it cannot flow from here to here. This is why from here to here, because this one here, the current source, is from top to down. Therefore, this bottom to up, left to right. Therefore, the voltage here must be negative. All right, following similar per simple. For this, for example, for this one here is must be negative R. This must be negative 2R, negative 24R, negative 8R. Thank you. And hopefully this is helpful for understanding basic inverting op amp. Thank you. Bye.